Okay, let's have a look again at this example of a simple student database system. So it has two classes, student and module, and the relationship between them. And we created a use case, and that use case we can view and change by looking at the KM3, which is the textual form of the specification. So this is package, class student with its attributes, indication that it's an identity, and the list of modules is represented as a reference, and module as a class with the opposite relation of class list. The use case has three parameters, and at the moment it's got no functionality. This is a use case to register a student with a given ID, given name and age. We can give it a functionality by adding a post condition, and post conditions express logically what the use case will do. Now we want this register student to create a student, and the way to specify that is to write in OCL that student exists a student with the given names. So student ID equals the ID, and the student name equals the input name, and the student age equals the input age. That creates a student with the given values for the student ID, name and age. If the student doesn't already exist, if the student does already exist, then this does nothing. We also would like to report the fact that this creation has taken place, so we can say student student id created, and the way to display that is to write a display statement which is treated as a logical statement. So this post condition, this constraint, says create a student with the given values, input values, parameter values, and display the result. Normally you don't need to change any of these. So that's now defined a use case. Again, we can look at the code and see that change has been made. We've now got a post condition there. Generate design is used to turn that logical specification into something which is translatable into code in different languages, and then we can go ahead and generate code as before. We can generate Java 7, and the executable version of that specification appears at the end of the coding here as the definition of the register student. Register student is essentially a global operation of the system. So we can then compile that code. The GUI gives a simple interface for the system. In this case, there's only one operation that can be done, and it asks for the input values. We're going to index the students by a number. We can have any name, Fred, aged 19. Student 1 created, we can do another one. Student 2. student 2, Sue, aged 20, and we create those two. Now, what does that do? Well, it creates a couple of students, and we can see the resulting model by saving the model that's been created. And that saves the model to a file called out, which is just a text file, but it shows the individual students, student 0 with the details for Fred, student 1 with the details for Sue. This is a way of checking that your program does what you expect it to do. Now that model can then be used as input for further operations. So the default output model is called out, but the default input model is called in, naturally enough, and so we can use that then if we want to rerun the user interface from a given point, we can load the model. That loads that model. That's now got 2 students in there already, so I will need to create a different student. Student 3. If I now save the model, I have a model with 3 students. Okay, let's go on to generation of other languages, such as Python, in the next part.